Hey guys, welcome to another video, and today we'll be looking at vectors, right? So, a vector quantity is the opposite of a scalar quantity. So a scalar quantity is any quantity that has only a size or a magnitude, right? And a vector quantity has both a size as well as a direction. So the direction can be that it's going up, going down, left, right, or we can denote it when we're writing it as a positive or a negative number, right? So here we have quantities that are grouped as scalar or vectors, right? So for scalar, we have time, temperature, length, energy, distance. Because these values, when we write them down, we just normally write the number as well as the unit. So we don't say time is going up or down, right? Vector, we have force, momentum, velocity, acceleration, displacement. So all these vectors here, we denote them based on which direction it's actually going, right? And then a vector is represented just by an arrow, right? So an arrow, the length of the arrow tells us the size or the magnitude, and the arrowhead shows the direction in which it is going, right? So a resultant vector is a single vector, just one vector, that gives a total of different vectors. So if we have different vectors acting on a similar object, then the resultant is what's the total vector that's acting, right? So we know that if they are going in the same direction, to get the resultant vector, we add. So in this case, we have a 3 and a 4 newtons going to the right. So therefore, our resultant would be 3 plus 4, which is 7 newtons, and it's also going to the same direction, which is right. And in this case, we have a 2 and a 3 meters per second squared, acceleration going to the left. So the resultant will be 3 and 2, which is 5, also going to the left, right? Now, if it's opposite direction, as in this case, we have a 2 newtons going right and a 3 newtons going left, then our resultant would take the form of the higher vector, which is a 3, so it's going to the left, and it's 3 minus 2, we get a 1 newton, right? And in this case, we have both displacement, one going left, which is 6, one going right, which is 6. So if we minus, we get a 0 meters. So 0 meters here shows that there is no resultant in displacement, because you go forward 6 and then you come back to your original position 6. So you were not displaced. Alright, so we're going to look now at resolving vectors that are actually acting parallel to each, that is perpendicular to each other, right? Because these were parallel vectors which we add or subtract. Now we're going to look at if the vectors are acting at an object if they are perpendicular. Alright guys, so we have two examples here of vectors that are acting perpendicular. So let's say we have a box here and we have a 3 newton and a 2 newton force acting. So the 3 newton is going to the left while the 2 newton is pushing it to up or north, right? So just by looking at the diagram here, you'll notice that your resultant will cause the object to go to that somewhere in that direction, right? So the first thing to resolve vectors is that we rearrange these two vectors without the object, right? Now, I normally use two ways. So we either can use the triangular method, which is by arranging your vectors to actually create a right angle triangle, right? And in that case, we always connect the head of one to the tail of the next. So in this case, we had drawn the 3 newton first, right? We can't change the direction, so it's always going to the left. Now to connect the 2 newtons, we either can connect here, still going up, so head to tail, or we can connect here, going up, head to tail, right? So therefore, we connect this or hypotenuse, which gives us a resultant, right? And a resultant always go to the direction that all our vectors are pointed, right? So we can do the triangle method, or we can use the square method, which is basically we join the objects tail to tail, right? So join the objects tail to tail, and therefore your resultant acts in that position there, right? But I find using the triangular method is way easier, so I'll show you with the triangle, right? So head to tail connection, so therefore resultant R is going like that. So because this is now a right angle triangle, we can use Pythagoras theorem to find the hypotenuse R, which is the square root of 3 squared plus 2 squared. We get 3.61 newtons, right? So now that's just the size. Let's look at the direction. So the direction would be to find the angle. Now the angle is at the tail of your resultant, right? So we don't find it at the head, we find it at the tail. So in this case, we use sine because we have all three sides, so we can use whichever one you choose. So we're using sine, which states that sine is the opposite over the hypotenuse, right? So it's sine inverse of the 3 over r, which is 3.61, and we get 56.20, right? So now we have the size and we have the direction. We write a statement now to conclude what we have just calculated. So the resultant is 3.61 newtons, which is acting 56.20 degrees away from, and it's acting away from our 2 newtons, right? So that's how you get for this question here. Alright, so let's look at the second one. Now the second one is similar to the first, but in this case we have 3 forces instead of 2, right? But it's stayed because these 2 forces are acting perpendicular to the 4 Newton there. So because these 2 are going in the same direction, right? Remember from previous, we know that same direction means we add. So 6 and 4, we get 10, right? And then 4 is just going down there, so we have 4. So if you notice, our connection here is a head and a tail, right? So therefore these forces would cause the object to go in a slanted direction like that, and that's what we see here for R going in that direction there, right? So again, to find R is the square root of 10 squared plus 4 squared, which we get 10.77 newtons, right? And then we find the angle. Remember, the angle is always the one at the tail of your resultant, and in this case we use tan, right? So tan is the opposite 4 over the adjacent, so adjacent to the angle 10, so 4 over 10, and we get 21.80 degrees, right? So therefore R, which our statement to finalize that R is 10.77 newtons acting 21.80 degrees away from, it's acting away from the 10 Newton force. Alright, so guys, I'm going to leave you with one question that you can try, and you can state your comment below what you got for your resultant as well as for your direction. Alright guys, so this is our question here. Let me just read. So an object is moving with a velocity of 5 meters per second in air to the left, and while it experiences a 2 meters per second resistance acting downwards. Calculate the resultant velocity of this object. Alright, so this is your question. Please leave your comments below of your answers for your resultant as well as your direction. Alright guys, thanks very much for tuning in to another class which we looked at vectors. Alright, please ensure that you leave your comments here of what you got for your answers. See you next time.